I would like to present Mr. Yang, a senior software engineer at Lance-Pytorch. Please give a round of applause to welcome Mr. Yang.
Okay, hello everyone. Thanks for joining here. And I was listening to the last speaker, and I found there are some conflicts between our ideas, but I think we can learn from each other. Okay, let's get started. Today I'm talking about the changes people are facing in AI training, and particularly at massive scales, and how we can make it easier and efficient. You can see that. Sorry. Oh, okay. Thank you. We can see that the training data is getting larger and larger, and the tabular data is just 145 bytes per row, but now we are see the embeddings are 25 times larger, and image is 500 larger, and the videos are even bigger and bigger. So the training data is the training data can quickly reach terabytes in size. And at this time, it's being generated at thousands of tokens per second, because we are not only training on human-generated data, but also the large language model generated data. And we can see that the training data is growing, and by a factor of 1,000 times every few years. So to manage such massive data, we can turn to a new cap theorem. But unlike the cap theorem for database, that's an unsolvable problem. But I will show you this is solvable. So to train the AI model, first we need to filter the data set to select the data we are interested in, and then we need to shuffle it, because we don't want the model to see the same data in the same order, because that would make the model learn some time-related pattern. That's not what we want. So we need to shuffle the data. But shuffling means we need to do random access. And so the random access performance matters for training. And finally, we need to stream the data to the training workers in a distributed system. And typically, these data are from object store. And so if you look at the existing systems, they can be good on one or two, but not all three. And I think for now, the industry we have some solution, but you can see this introduces complexity, and the second challenge is the data management. Today, people overuse multiple systems to train the AI model on massive data sets, which requires duplicating the data into each system in its own format and for its own purpose. And so these copies not only increase the storage costs, but also demand significant human resources to manage it and keep these data copies in sync. So it's very painful and over complicated, and it's a waste of skills, because you need to spend much time on managing this data, not instead of improving your model. So what if we can have it all? So this is our solution, the Lance format. The Lance format is designed for AI workloads and built on top of object store. So it's a columnar format, so you can do fast scan, and with advanced encoding, it supports O1 random access, and the large blob is stored inline, so you can stream them efficiently, and we know that for the next generation file format like parquets and ORC, they have the concept of row group, and I believe many people here must run into the problem that to select a proper row group size, because today we're storing many columns in a data set, and this data set can contain many columns, and some columns are some columns are large, but the other ones are small, so a proper row group size is not possible to select. So in Lance format, we removed the concept of row groups, and the Lance format is optimized for modern storage devices like NVMe and object storage to reach better performance and flexibility. And so for AI workloads, we also build some AI native features like versioning. You can tag and track different versions of your data, and no need to create copies. And an important feature is the zero copy schema evolution. That means you can easily add new columns to your dataset without duplicating columns. And this feature is what that has been very popular with our users. And for faster scan, for faster search performance, you can build index directly on a Lance file, including B-tree and FFPQHW for vector search, and you can even do full text search on Lance format, on Lance format. Okay, so one of our users is Midjourney, and Midjourney is using Lance to process 1 billion vectors, and they got 50 times cost efficiency. And I think the most of the feature they love is the zero copy schema evolution feature. We will find some new feature for machine learning, and then you want to add new columns for them. With Lance, you can easily do that. And current AI is also using Lance because they want to do filter and vector search and full text search. So with Lance, they can do all the 3 in 1, and with very fast performance. So here is a script that show you how to do a vector search on a Lance format, on Lance file. It's a straightforward. I just want to select the top 10 results and select the ID and the title columns. The results are in PyArrow table. so you can still manipulate the results with your familiar ways. Also, we need to change only one line to do full text search. And you can even run circle on a lens file because we have a error compatibility layer, and so you can access you can query it with a circle with DuckDB. And so finally, we designed our APIs to integrate seamlessly with tools that machine learning engineers are already familiar with, such as packet arrow and panels and circle. And this makes it easier for you to manipulate and measure your data. What we're always doing is make it developer friendly. And I know it's a short talk, so no Q&A, but if you have any question, please join us on Discord. Thank you.